Hey guys, this is Jumel. So today I'm going to show you how to get the length of the string in assembly. So let's start with our section data. Section data, and then let's call it text, a variable name, and then let's say please enter. Oh damn it! Enter string space. And then let's have a section dot bss. Instead of section dot bss, let's have a variable called, or let's call it a string. And then it reserve. Let's say it reserve a byte. Let's say it reserve 1000. Or let's say maybe 10. 10. 1, 2, 3. Okay. And then let's have a what? Result, which also reserve a byte, which is 1. But what if that thing is more than 200 something? Let's use a double weight actually. Let's use a double weight. I just say double weight and then I typed it, let's say 1. And then say section the text global and underscore start. Start. Okay. Then you'll know in C++, just have to say please enter enter string, and then okay space. So in assembly we're going to do it this way. So RAX, and then it's 1 for cout, RDI 1, move RSI, and then variable name move RDX, and then string length is 21 is call, and then cin to get the input from the user. Cin, then it's a string, we call it a string like that. So it's a move RAX 0 for cin, RDI 0 for cin, move RSR, and then it's a string, then move RDX, and then we don't know the length of the string. Let's use that 10,000 there. This is call. So you got your string. Now we want to know the length of that string. What you're supposed to do, we have a conditional jumps. I'm going to say jumps, and then let's end on length. So let's start with C++. In C++, in order to read something, you have to have integer. Let's call it count is equals to 0, and then you start by having a for loop. You can have a for loop or while loop or whatever loop. So I is equals to 0, and then I. In C++, it's not I. Let's say, because in C++, do we have a what you call it, a new characters at the end? I don't think we do, but let's just do it this way, and then say I is not equals to null, and then I plus plus. So also we say count plus plus. Okay, that's how it's supposed to be. Okay, in assembly, what do we do now? I love to use RCX, so just say RCX. We claim that RCX, and then it's 0. Then we start by incrementing inside the loop. Then we increment RCX, and then we check CMP. Then it's a string. Then we say byte. Then we say the name of it, of our variable plus RCX, and then which is a character that we are looking for. It's 0, the character that we're looking for, which is null. Then jump. If it's not equals to, then what do we do? We jump back to that part, and make sure we don't need this part. Okay, and then you have your length inside your RCX, but it includes null at the end. So we're supposed to remove that null first. So we did remove that null, and then let's clear our register code. RAX. Okay, I cleared my RC. Actually, let me use EAX. I cleared it. Then move RAX also, and then, but one of them, if you play it, it will still work. And then I said move RAX to store RCX, and then said okay, and then I clear my ADX with ADX, and then I move. Wait, I don't know the length of that thing. So since I don't know the length, okay, you're not supposed to use it this way, because this way it means you know the length. So what is supposed to do? We're supposed to store it somewhere first, and then we have to loop through it. Okay, let me write the termination part. Nation RAX 60 move RTI 0, and then don't forget 6 call. Okay, so okay, let's do this one here. Let's clear RAX actually. RAX with okay, we cleared it, and then move RAX to store RCX, and then we have a loop. Let's call it push. This loop, call it push loop. Yeah, this is our push loop, and then it has an end push loop. So inside this part, what we're supposed to do, we're supposed to get the last value at the end, and then we push it to the stack, and then we get the second last value. Push it to the third, the fourth, the fifth, until we find the first one. So this part we say CMP array X. Okay, CMP array X not required with 0. Jump equals to the end of this part. It will jump only if it's equals to 0. So, and then what we do here, we clear our RDX with RDX, and then we move RBX to store 10, and then we divide RBX by 10, and then we add RDX with 48, and then we push RDX to stack, and we push RDX to stack, and then we use it unconditional jump. We jump back to this part, then we jump back to this part, push until the last one. Remember, the reason why we have to say, the reason why this part we have to say 0 is because quotient, if your RX is 0, your quotient also will be equals to 0. That's why I said 0, because remember, if you have a 10 and then you say 10 divided by, you say 10 divided by 10, the remainder will be 0, and then the quotient will be 1. And then when you say 1 divided by 10, the remainder will be 1, but your quotient will be 0. You get it? That's how I used to do it. So then I push everything to a stack. This part will push everything until when array exits 0, then it will stop, and then it will terminate my loop. Then I push it everything, but I don't know something yet. What I don't know is how many times did I, what do you call it? How many times did I, how can I put this thing? I entered a loop, my loop. How many times did I looped through this thing? So let me use RCX again. So it will be easy when it's coming to pop RCX, and then it's there, say that thing, and then I increment my RCX. RCX. It will increment it, and then now it's we have to include pop loop. Where in our pop loop we just pop RDX, and then after popping our RDX, and then we can clear our register RAX, clear with RAX, because since we don't have things called anything that is code. Okay, then say move RAX with RDX, and then after moving your RDX, so since RDX is only 1 digit, it's easy to use it as a byte part. Say byte, and then we use our string. We can use our string reusing something, and then using AL, and then after using AL, so now we can output it. Remember that when it say outputting something, we also RAX1, move RDI also 1, and then move RSI, and then string, and then move RDX, and then 1, and then don't forget our sys call, and then we decrement RCX, and then CMP RCX with 0, then jump not equals to to pop loop. Okay, so let's check if we didn't make a mistake. Okay, make it's unexpected end of a line after 70. Wait. Say unexpected. Oh, I get why. Okay. Create, make, okay, did run. Let's say user GDB and task. Okay, let's start by checking our things. Let's end up here, break on line 40, break 40. Say it's a task, but it says there's no things called a task, not loaded. Then how task? Yeah, it's a task. Then what I can? Okay, let me just check here. Or create a task 3. Oh, okay, our problem it was here. Okay, so we did got our problems. Okay, now we have to create, make, use GDP, and then break line 40, then run. Let's enter a string. Hello world. Hello world. Hello world. Let me just copy the string until this correct. Wait, it's from here to here, yeah. And copy. Let's see the length of that string first. The length of that string is 12. Hello world is 12. So let's see. Then let's print or RC or RCX. It's 12. It's our length is 12. Okay, which means it does work. So let's create it, and then we can use let's continue with our GDB. And now let's check we ended on that part, and then let's run it. Actually, let's just run it, and then hello world. Segmentation fault at the pop pad RDX. Did I? Oh, I did push RDX. When it's 0, jump not the customer. Wait. The first thing it will pop. Just one increment. Oh, it's 0 here. And then the second part, it will push again 1. It will push 1. And then on the side, I'll pop it 1. And this one, it will be 1, 2, 2. Wait, 0. It will say 1 and 2. And then this side, it will pop and include to this decrement it, and then check if it's this part, and then pop again. RCX must be 1 and 0 because it's 2. Decrement it to 1, decrement it to 0, then it's equals to 0. Why is it a full? Oh, wait. Oh, it creates infinite while loops. Oh, there's an infinite while loops, that's why. No, like, if it's working like this, okay, let me just use that as well. At mine. Increment, oh, damn it. At 9. At 9. Okay. Make it clean. Make. Okay. Oh, this thing. Oh, task. And then hello. Oh, let's see. Oh, I just made it cleanish. Make. Run. Hello world. Again, it's 12 and then it still continue. Oh, it's, oh, guys, just I can make a silly mistake like just silly mistake. Okay. Why? I don't want to use this thing. I want to use make clean. Make clean. Make GDB and then run. And then hello world. It's 12. It's 12 here. So, guys, this is how you do it. Oh, I know why. The reason why it was give me infinite while loop is because every time when you're using this part and then system call, RCX is a counter register, is going to store something every time. So you're not supposed to use this kind of stuff, RCX, when you're looping something. Maybe use R9, R10, R what, but don't use RCX because it might give you some problems. So I think this is where I end, guys.